Hello there, CP Finite. Welcome to lesson 1.4. Today's lesson, we are going to be discussing and finding correlations of data. Okay, correlations, something you might have come across in the past. Basically, a correlation is a relationship between two variables. A correlation is a relation. Hey, that's in the word. It's a relationship, okay? They can be of various types. So they can be positive. So on a graph, maybe it's a positive correlation, okay? Something that would look like a positive correlation. Let's say that, okay, time is on our x-axis, and money is on the y-axis. And generally, the more time that you work in particular, the more money you make. Those things are strongly correlated for the most part, okay, depending on the context. So time that you're working, strongly correlated. A positive correlation, okay, some things to note here. It's going up from left to right. So positive correlation is going up like that there. As one variable increases, so does the other variable. Another type is a no correlation, okay? So sometimes things can have no correlation whatsoever with one another. On a scatter plot, what this would look like is just dots all over the place. So something that would have no correlation perhaps, maybe the number of puppy adoptions, okay? Puppies, oh, they're so cute. Compared to, let's say, your grade in this course, or your grade in classes, okay? So something like that, maybe you're like, well, the more puppies get adopted, the happier I am. In general, your grade has nothing to do with the number of puppy adoptions. So we say there's no correlation or zero correlation there. And the last one is a negative correlation, okay? For example, the more of something that happens, maybe the less of an outcome. So a negative correlation, something that might be negatively correlated, let's say again over, let's say over time once more. So as time progresses, you could say your energy decreases. Okay, so throughout the day, energy decreases as time goes on. So general correlations. Now, there are strengths of correlations, and that is determined by what's known as the correlation coefficient, or the R value, okay? The R value or correlation value. And if you're in business or if you are looking at trends, this is important, okay? There are many studies done out there that find correlations and determine strengths of things. It's really fascinating. In general, it's a continuum. It's a line here. So our R value, it's going to range between two values, -1 and +1. And then in the middle is 0. Okay? Now, strength of a correlation, everything in the negatives, okay, these are all negative correlations. Whereas everything in the positives, these are all positive correlations. Stronger relations occur between the closer you are to 1. So strength it's a stronger correlation if you are closer to -1 or +1. Okay, typically numbers like if you have a correlation of 0.75 to 1, we'll say those are a little bit in the strong category, or -0.75 to 1 about. The closer you get to about 0.5, negative or positive, it's a weaker correlation in between there. So strong, you could say it's a little weak in between here. and even to the negative 0.25 or positive 0.25. And generally, if it's within the range of negative to positive 0.25, that's a very, very weak relationship, or more of no correlation, okay? Again, you'll have different examples fall in different areas, but just know that a strong correlation, and that is going to resemble a strong line here. So like this number 1 here, or this first example, it's very compact, very close to a line, which means they're strongly related. So the R value, it would be closer to 1, maybe a 0.98 or something, because it is strong, okay? In the middle here, this would be probably a 0 correlation. R would probably be about, I don't know, just 0 or 0.1, okay? And for this one, if we just add a few more points, okay, the general trend is that they're decreasing, but this one would probably have a weaker correlation, maybe around 0.5 or something like that. So that's what we're talking about as far as strength of correlations. Okay. The next part is finding that R value and finding the linear regression or the linear trend line. Okay. One thing that is very linear are the minutes you spend exercising and the calories burned. So we're going to plot these and essentially find our little value in the graphing calculator. You will need the graphing calculator for this here. So first, creating a scatter plot. Again, these are some examples that you can kind of have different graphs, but generally always include labels of the axes and do your best with making it even units. So we have minutes on our X, and we have calories burned on the Y. Minutes, we're ranging up to 55, so we can even go by 5s here. 5, 10, 15, 20, 25, 30, 35, 40, 50, 55, 60, okay. And calories, it looks like if we go by 10s, we'll be okay. 10, 20, 30, 40, 50, 60, 70, 80, 100, 10, 20, 30, 40, 50, 60, 200. Oh man, gonna run out of space here. 20, 40. We'll finagle a little bit. Let's do 25s. 25, 50, 75, 100. Sorry. 200. 300. Okay. It'll get the job done no matter what you do. So let's just quickly plot this. If you want to jump ahead, you can. We're looking at 15 to 50. So 5, 10, 15, and 50. There's our first point. 20 to 60. 10, 15, 20. And that's going to be about there. 80 is 25. 30 is 110. And 35 is 135. And so forth. 25. And 45 right before there. And 170. Right before there. 210, so 50 to 210 jumps a little bit. And 55 to 50. Okay. So generally looking at this right away, I know it's not perfect. You can see it's pretty straight. We would expect a pretty strong correlation. Now, for finding the equation a line travels through the points, so this is known as the line of best fit. I'm actually going to let you use your calculator to do this. Okay, so let's fire that up and get it ready. So calculator to find line of best fit. Please, again, have that with you, have that out, and closely follow along here. So we're going to find the equation, the line of best fit. Okay, first step with your calculator is please, let's make sure we're all on the same page. Clear out the RAM, which is second plus 712. Okay, if that's cleared, we're all kind of on the same page right now, so that can be helpful. Now, we are going to eventually find the diagnostics and the correlation, so let's go ahead and do that already. We have to turn the diagnostics on. So to do that, we are going to go to the catalog, which is second 0. Okay, so skipping ahead here, second 0, that takes you to the catalog. And you want to scroll down until you get to diagnostics on. It's going to take a little bit, but you can get there. And we'll say diag on. Almost there. These are all the operations in your calculator. There it is, off, and we want on. So just hit enter and enter. It'll just say done. So make sure you turn diagnostics on. After that little bit, we can start plugging things in. So next, let's actually graph this. Let's go to y equals. To turn the scatter plot on, if you just go up to plot 1 and hit enter, and you go down, see how it's dark now? Up here, okay? That means it's turned on. So real quick, off, on, okay? Off, on. Next, let's go to stat edit L1, L2. So stat edit list 1, we are going to let be our minutes. So we can just type in the 15, the 20, the 25, the 30, 35, and so forth. List 2, we will let be the calories. So 50 and 60 and so forth. I know, not thrilling, but it's pretty neat what our calculators can do here. Okay. Before we do anything else, just make sure the data matches up. So a little check, make sure the data matches up, that you typed everything in okay. And what I mean by that is you should have the same number of things in L1 as you do in L2. Okay. Now, a few different things we can do is we can, if you want to see what this looks like as a graph, and you go to zoom, and if we actually go to zoom and we scroll down to stat, that's going to show you our relationship. So if you want a little extra thing here, zoom stat shows you on a graph what it looks like. Now the main thing is finding this line of best fit. The line of best fit are these directions here. Stat, calc, lin, reg. Okay, so we're going to do stat, over to calc, number 4, and you can just keep hitting enter. Now, if you turn the diagnostics on, like I explained, you'll also see a few other things. So I see a few things going on here. Y equals AX plus B. That is just our general form of an equation. So what we have is it's telling us what A is. So we have Y is equal to 4.88x minus 36.47. And that is the equation of the line of best fit. Now, the R value at the bottom is 0.988 essentially. And remember, R value is the correlation coefficient. And thinking about what that means, it's close to 1, it's 0.9. This means it's a strong positive relationship. Okay, so as expected, the number of calories is strongly related to the number of minutes on the elliptical. Okay, so that is graphing calculator. Now, a little follow-up question. So what we can do with this information is now we can estimate how many calories would be burned in any given amount of time. So let's say you want to spend 80 minutes on this elliptical. Well, we can just use our equation of the line of best fit and substitute in 80. So 488x. We're actually going to use 80 for x. And minus 36.47. And that'll tell us how many calories we burn over that amount of time. And that would be about 353.93 calories. Yeah, you could round, it's no big deal. On the other end of the spectrum, maybe you're working out and you want to know how long is it going to take for you to burn off that donut or whatever you ate too much of. So, fun fact, I believe 1 pound is equal to 2,500 calories. I think that's what essentially a pound of fat is. I think so. Don't fact check me on that. So let's just say, even in general, let's just say how long will it take on the elliptical to burn that? So how long to burn $2,500 calories? Now, in this case, let's just think. So our example, remember our equation, x is time, y is calories. So in this example, we're going to have 2,500 is equal to 4.88 times x, which is time, minus 36.47. And then we're solving for x. So let's see how long it would take to burn all that off. We're going to add 36. So we have 2536.47 equals 4.88x. Yep. Divide by 4.88. And that means we're going to have to spend 519.77 minutes to burn off that extra pound. Okay, so that's quite a bit of long time. So anyway, line of best fit, please be practicing, especially in your graph calculator, how to do that. As long as you know how to do it in your calculator, you don't have to worry about doing it by hand. And there are some practice problems for you to consider. So great job, guys. Let me know if you have some further questions.